Hello class, welcome to part 2 on CAMS. In the first part we have seen the various types of the CAMS followers, then also we have seen the velocity, displacement and acceleration time curves for different types of motions of the followers. Now in this part we will see by taking some numericals how the displacement diagram and CAM profile can be constructed for given type of motion of the follower. Now in this case we will take up a knife edge follower which is moving with uniform velocity. Knife edge follower moving with uniform velocity. So here knife edge follower is there. For that a problem we have picked up. A CAM is to give the following motion to a knife edge follower. Outstroke during 60 degree of CAM rotation, dwell for the next 30 degrees of CAM rotation, return stroke during next 60 degrees of CAM rotation, and fourth, dwell up for the remaining 210 degree of CAM rotation. The stroke of the follower is 40 mm and the minimum radius of the CAM is 50 mm. The follower moves with uniform velocity during both outstroke and return strokes. Draw the profile of the CAM when the axis of the follower passes through the axis of the CAM shaft, that is center of the CAM shaft, and the axis of the follower is offset by 20 mm from the center of the CAM shaft or axis of the CAM shaft. Now we will construct the displacement diagram as well as the CAM profile for the given conditions. Now what is given in this problem is the motion of the follower. For 60 degrees of the CAM rotation, the follower moves from its lowest position to its highest position. Then second, for 30 degrees of the CAM rotation, it remains stationary. Station means dwell. Then for the next 60 degrees of CAM rotation, the follower will come down, return stroke. And for remaining 210 degrees of CAM rotation, the follower will remain stationary. That means here for one revolution of the CAM, that is 360 degree rotation of the CAM, there are four motions of the follower. The rise, that is outstroke, and dwell, and return, and again dwell. And sometimes there may not be dwell, okay, and sometimes there may be two dwells after rise and after return. Now here, so this is the lowermost position of the follower and this is the highest position of the follower, and this is called as the lift or stroke of the follower. Okay. Now let us construct the displacement diagram for the uniform motion of the follower. It is given that the follower moves with uniform motion during the rise period and also during return period. Now the procedure is very simple for of constructing this displacement diagram. First, draw a line AB. Then what should be the length of this line AB? This line AB should represent 360 degrees of CAM rotation. But here on paper we can use some scale, like for example 10 degree equal to 1 centimeter, or 20 degree equal to 1 centimeter, or 30 degree equal to 1 centimeter. Like that we can choose some convenient scale to represent some amount of angle of rotation by a linear scale. So here we have chosen the length of this AB as 18 centimeter, means 360 degree of CAM rotation. So AB represents 360 degree, and in here it is represented by a line of length 18 centimeter. Okay. Then after drawing this horizontal line AB, from A draw a line A dash, which is equal to the given stroke or lift of the follower. So lift of the follower here, it is given as 40 millimeter. So A dash is 40 millimeter long. When this AB and A dash are drawn, complete this rectangle A dash, B dash, B. Okay. Then after that, you have to mark the first portion of rotation of the cam or the first motion of the follower, that is outstroke. So outstroke is for 60 degrees of cam rotation. So this AD represents outstroke of the follower. So here mark AD. So we know that 360 degree equal to 18 centimeter. 60 degrees means how many centimeters? So it is 3 centimeters. AD will be 3 centimeters. Okay. So this 3 centimeter here length will represent 60 degree. Then first dwell is for 30 degrees. So 360 degrees means 18 centimeter. 30 degrees means how much? 1.5 centimeter. Similarly, EF is the return stroke of the follower. Again, it is for during 60 degrees of cam rotation. So here outstroke is for 60 degree, that means it is 3 centimeter length. This should also be 3 centimeter because return stroke is for during 60 degrees of cam rotation. Now draw perpendicular lines from D, from E, F. Okay. Now next step is to divide this outstroke AD into equal number of parts, preferably even number of parts. Here this has been divided, AD is divided into 6 equal parts. Similarly, you divide EF also into 6 equal parts. Okay. And FB is what? It represents 210 degrees of cam rotation during which the follower is stationary. Okay. So D dash E dash, this and FB represents the dwell period of the follower. So that is how the displacement diagram of a follower when it is moving with uniform velocity is constructed. Now if you join A T dash, this represents the uniform motion of the follower. This also uniform motion of the follower. Now you have drawn the lines from these divisions 1, 2, 3, 4, 5 vertical lines. Similarly from 7, 8, 9, 10, 11 you have drawn also the vertical lines, and after connecting A D dash and E dash F, wherever this line intersect the vertical lines, mark them as 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, and this as 6 dash, and of course initially O. And similarly here, wherever this line which is connecting E dash and F intersect the vertical lines, name them as 7 dash, 8 dash, 9 dash, 10 dash, 11 dash, and of course last point is 12. So now after constructing this displacement diagram of the follower when it moves with uniform motion or uniform velocity. Okay. Now next is to construct the cam profile using this displacement diagram. For that, what you should do? First, you should draw a circle by taking a radius of 50 millimeter, because the minimum radius of the cam is given as 50 millimeter with center as O and radius equal to 50 millimeter. Draw a circle. So this is the base circle having minimum radius of 50 millimeter, and this is the knife edge follower. Let this axis of the follower pass through the center of the cam. Okay, the first case is when it passes through the axis of the camshaft or the cam, and now A is the tracing point. Now one thing you should understand, while constructing the cam profile, you should keep the cam stationary and rotate the follower in a direction opposite to the rotation of the cam. Here in this problem it is not given in which direction the cam is rotating. So we will assume that the cam is rotating in the clockwise direction. Hence, you must rotate the follower in the anti-clockwise direction for constructing this cam profile. Right. So this is the reference line. OA is the reference line. Now with respect to OA, measure 60 degrees, which is the rise. This AD should be equal to angle AOD is 60 degrees. And divide this angle AOD into same number of parts that you have divided this rise period. AD you have divided into 6 parts. Similarly, angle AOD must be divided into 6 equal parts. Then next is dwell period, which is for 30 degrees. From OD measure 30 degrees. So this will be your means DE, this one. Then next is your return period, E dash F. Okay, from here to here measure 60 degrees. Angle EOF is 60 degrees, and also you divide this angle EOF into 6 equal parts. So now this is angle AOD, which has been divided into 6 equal parts and marked as 0, 1, 2, 3, 4, 5, 6. And from the center of this cam, passing through these points, draw the radial lines. From O passing through 1, draw a radial line. From O passing through point 2, draw a radial line, and so on. So from all these points, draw these radial lines. Now next is very important. You have to shift or transfer the lengths. So this is it. First tracing point corresponds to this here, A and O. Second, 1 dash you have to measure. Measure this length and then transfer that length onto this first radial line, 1 dash. Similarly, measure 2 dash and transfer that onto this radial line, 2 dash. Measure 3 dash line and transfer that on this line. 4 dash you measure with 4 a center, mark 4 dash, and this is 4 dash corresponding to this. Measure 5 dash and transfer on this. 6 dash, transfer on this. So you have got these set of points on these radial lines. So these distances are nothing but distances transferred from this displacement diagram. These distances. Okay. Similarly, 6 dash, here it will be same. Okay. And then from this point onwards, 7, from 7 dash you measure, shift here, 8 dash, shift here, 9 dash, shift here, 10 dash, shift here, 11 dash, shift here, 12 is the last point here. Now join all these points by a smooth curve, by freehand. Join all these by smooth curve, or you can use the French curves, and then what you get is the profile of the cam when this follower is moving with uniform velocity and when its axis is passing through the center of the cam. Now the second part is the construction of the cam profile when the axis of the follower is offset by 20 mm from the axis of the camshaft. So here in this case, the axis of the follower is offset by 20 mm from the center of the cam. Now in the problem it is not given whether it is on the left hand side or in the right hand side. Here we have taken it on the right hand side. The follower axis is shifted by 20 millimeter from the center towards right. Now this is the one where the axis of the follower passes through the center of the cam. Now only difference is here is the reference line for marking the angles is this OA. So connect the knife edge at the center. So OA will be the reference. With respect to this, we have to measure the angles. So with respect to this, the 60-degree angle, that is outstroke, is measured. Similarly with OD, 30-degree dwell is measured. Similarly with respect to OE, return stroke 60 degrees measured, and rest of the angle is 210 degree. And rest of the procedure is same. From the displacement diagram, you shift all the distances here on the respective radial lines and join them by smooth curve. So that is the only difference between the construction of the cam profile when the follower passes through the center and when it is offset by some distance from the center of the cam. Now the second problem is a problem where there is a roller follower which moves with a simple harmonic motion. This is the problem. A cam with a minimum radius of 25 mm rotating clockwise. Here the rotation of the cam is given. Rotating clockwise at a uniform speed is to be designed to give a roller follower at the end of the wall rod motion described below. The rise of the wall through 50 mm during 120 degrees of the cam rotation. So here 50 mm means it is lift or stroke of the follower. So here it is a wall rod. To keep the wall fully raised during next 30 degrees means the wall will be open for 30 degrees of cam rotation. Then to lower the wall during next 60 degrees of cam rotation. So during next 60 degrees of cam rotation, the wall will return back. Then to keep the wall closed during rest of the revolution of the cam, that is 150 degrees. Now the diameter of the roller is 20 mm and the diameter of the cam shaft is 25 mm. Draw the profile of the cam when the line of stroke of the wall rod passes through the axis of the cam shaft and when the line of the stroke is offset 50 mm from the axis of the cam shaft. Again here it is not given whether it is to the left or to the right. Okay. Determine the maximum acceleration of the wall rod when the cam shaft rotates at 100 rpm. Draw the displacement, velocity and acceleration diagrams for one complete revolution of the cam. Now, this is the displacement diagram constructed for the roller follower moving with simple harmonic motion. Now, the stroke is 50 mm, so that means this is stroke, vertical height of this displacement diagram. And here again AX is 360 degree. You can choose some convenient scale to represent this. Then outstroke is 120 degree, 120 degree outstroke, 30 degree dwell, 60 degrees return stroke and remaining 150 degrees return stroke. Minimum radius of the cam is 25 mm, diameter of the roller is 20 mm and diameter of the cam shaft is 25 mm. Now let us see how this displacement diagram when the follower is moving with simple harmonic motion. So carefully listen. You divide this length AY midway, means bisect this. So C dash is the midpoint of AY. So that means the total height is 50 mm, then AC dash is 25 mm. Now with C dash as center and C dash Y or C dash A as radius, draw this semicircle. Draw this semicircle. Now divide this semicircle into 6 equal parts. Okay, 1 2 3 4 5 6. So this semicircle has been divided into 6 equal parts. Also, you divide this rise period AS into same number of parts, that is 6 number of parts, and also this return period TP into same 6 number of parts. Right? Now name these points on the semicircle as A, B, C, D, E. Now from these points draw the horizontal lines. From A, draw a horizontal line. From B, draw a horizontal line. C, draw a horizontal line. From D, draw a horizontal line. From E, draw a horizontal line. So that when you draw the horizontal line from point A, it cuts this vertical line at B. Similarly, when you draw the horizontal line from B, it cuts the second vertical line at C. Similarly, here at D, E, F. Similarly, here this line starting from E will cut this vertical line at J. This will cut this vertical line at K. Similarly, up to P. Now we have got the distances 1B, 2C, 3D, 4E, 5E, 6G, 0-H, 1-J, 2-K, 3-L. Right? Now next job is to construct the CAM profile using this displacement diagram. Let us see how it can be constructed. Now this is the procedure for constructing the CAM profile when the axis of the follower passes through the center of the CAM. Now first is draw a base circle with center O and radius equal to the minimum radius of the CAM. So with O as center and minimum radius of the CAM is 25 mm. So draw that circle. Now draw prime circle with center O and radius OA. This OA. What is that radius? Which is equal to minimum radius of the CAM and half of the roller diameter. So minimum radius of the CAM is 25 mm and roller diameter is 20 mm and half of that 10 mm. So 25 plus 10, 35 mm is the radius of the prime circle. So this is the prime circle. Its radius is 35 mm. So this is the minimum radius of the CAM plus radius of the follower. It gives the total radius of the prime circle. Then, now as the axis of the follower is passing through the center of the CAM, this is the reference line for marking the angles. So first mark angle AOS equal to 120 degrees with respect to this line AO. Okay. So this is AOS. AOS. Now divide this angle AOS into same number of parts. You have divided the outstroke, that is 6 number of parts. Then from this OS line measure 30 degree, this one, which is the first dwell, and then from OT measure 60 degree, okay, up to this point P. It is a return stroke, and again you divide this angle TOP into 6 number of parts. Okay. Now draw the radial lines from the center passing through these points. Okay, passing through these points. Now from this point 1, you have to locate point B. 1B. How do you locate? This, measure this distance 1B and shift this on this radial line. Similarly, measure 2C, shift on this radial line. Measure 3D, 4E, 5F, 6G and shift all those on these respective radial lines. Now mark those points as B, C, D, E, F and G. Now listen carefully. With these as centers, B, C, D, E, F and G as centers, and radius equal to radius of the roller, draw the circles. With B, draw a circle with radius of 10 millimeter. With C, draw a radius of 10 millimeter. With D, a center and radius of 10 millimeter, draw a circle. Similarly, with E as center, draw a circle of radius 10 millimeter. With F as center and radius equal to 10 millimeter, draw a circle, and so on. At all these, with all these centers, draw all these circles. These are nothing but the roller positions, because we are rotating this follower in this direction, keeping the cam stationary. In this case, it is given cam is rotating in the clockwise direction, so hence we have kept the cam stationary and rotated the follower in the counterclockwise direction. By rotating the follower in the counterclockwise direction, these are the positions of the follower. Now, after having drawn all these circles through these points, next thing is you have to draw a smooth circle such that curve such that it is tangential to all these circles. It is tangential to all these circles. That is the cam profile. So we have to draw a smooth circle such that it is tangent to all the circles which you have drawn. Now this red color is the cam profile. When the roller follower moves with simple harmonic motion and when the axis passes through the center. Now let us see when the follower is offset by some distance. Okay, it is by 15 millimeter, and in this case it is not given whether it is on the left side or right side, so we take on the left side, so it is better. Okay, now only difference is when the axis of the follower passes through the center O. AO was the center line. Now here in this offset position, connect A and O. This becomes the reference for measuring the angles. So first is 120 degree, AOS 120 degree, then angle SOT 30 degree 12 period, angle TOP 60 degree return period, and remaining angle POA or AOP is 150 degrees, that is again 12 period. Now what you have to do is, again you divide this angle AOS into 6 number of parts. So 1, 2, 3, 4, 5, 6, these are the numbers made, right? Now here note carefully that instead of drawing the radial lines from the center, you have to draw the lines from these points such that they are tangent to this offset circle. So what is the radius of this offset circle? 15 millimeter, which is given. Okay, so with this O as center, you have to draw this circle. Its radius is 15 millimeter, called as offset circle. Okay, so from these points you have to draw the lines tangent to this offset circle. Similarly, through 2 you have to draw a line which is tangent to this offset circle. Through 3, draw a line which is tangent to this offset circle. Similarly, through all these points. Then with these points as centers and radius equal to the radius of the roller, draw the circles. Okay, draw the circles. Then draw the curve touching these circles, means it is tangent to the all these circles. Thereby the profile of the cam is completed, constructed, this red color. Right? Yes, sir? You have got it? So what is this length 1b? This is taken from the displacement diagram, and with B as center, the circle is drawn and radius is radius of this roller. Similarly, from 2 C, this distance is taken from the displacement diagram with C as center and radius of the roller, the circle is drawn. Similarly, 3D is taken from the displacement diagram and the circle is drawn, and so on. And that is how, by drawing a smooth curve which is tangent to all the circles, you get a cam profile. So only difference between this, where the roller is offset, is you have to construct or draw the offset circle, and you have to draw these lines through these points such that they are tangent to this offset circle. That is the only difference. And by using the standard equations, when the follower is moving with simple harmonic motion, we are calculating the maximum velocity during rise, pi into omega and s. S is nothing but the lift or stroke, which is 50 millimeter. Similarly, maximum velocity during the return period, maximum acceleration during rise, then maximum acceleration during return. So the equations are there. By substituting the values here, that is the cam rotation during outstroke, cam rotation during return stroke, cam rotation during outstroke, cam rotation during return stroke. Only thing is, all these angles should be substituted in radians here. So when you calculate, this is the maximum velocity during outstroke, maximum velocity during return stroke, maximum acceleration during outstroke, and this is maximum acceleration during return stroke. So students, in this part we have discussed about how to construct the displacement diagram and a cam profile for a knife edge follower when it is moving with uniform velocity, and for a roller follower when it is moving with simple harmonic motion, and also when the axis of the follower passes through the center of the cam and when it is offset by a certain amount from the center of the cam. And in the third part we will see the procedure of constructing the displacement diagram and cam profile when the follower moves with cycloidal motion and uniform acceleration and retardation. Thank you so much, and we will see in the third part.